Hello all, in today's video we will be covering the topic geometric mean. Up till now when we were studying about averages or measures of central tendency, we have covered arithmetic mean, median and mode. Now we are left with geometric mean and harmonic mean. So today we will be covering geometric mean. So coming to geometric mean of a set of n observation is the nth root of their product. Mathematically speaking, geometric mean of n observations, that is x1, x2 up to xn, is given by g is equal to nth root of x1 multiplied by x2 and so on up to xn. Okay. So if there are 2 observations, we take the square root, and if there are 3 observations, we take the cube root and so on. Now we will see how log of geometric mean is the arithmetic mean of the log of the given values. We will see this for all the 3 series, that is individual series, discrete series and continuous series. So first, coming to individual series, consider geometric mean g of n observations x1, x2 up to xn. So geometric mean is given as nth root of x1 into x2, so continue till xn. Now if we take log on both the sides, log of g is equal to 1 by n log of x1 into x2 and up to xn. We know that log of m into n is log of m plus log of n. Applying that to log of x1, x2, x till xn, we get log of g is equal to 1 by n log of x1 plus log of x2 plus so on up to log of xn. This we can reduce to log of g is equal to 1 by n summation of I equals to 1 to n log of xi. So g is equal to nt log of 1 by n summation of I equals to 1 to n log of xi. So this was for individual series. Now let us see for discrete series.
So in case of discrete series, if the frequency distribution xi, fi, where I ranges from 1, 2 and so on up to n, the geometric mean g is given by g is equal to x1 raised to f1 multiplied by x2 raised to f2 and so on up to xn raised to fn and the whole raised to 1 by n, where n is equal to 1 by n summation of I equals to 1 to n f of I.
Now taking log on both sides as we did earlier, log of g is equal to 1 by n a whole multiplied by f1 log x1 plus f2 log x2 and so on till fn log xn. This we can reduce to log of g is 1 by n summation of I equals to 1 to n fi log xi. Thus we can see that the log of geometric mean is the arithmetic mean of the log of the given values. So g is equal to nt log of 1 by n summation of I equals to 1 to n fi log of xi. Now let us see for continuous series. In continuous series, the formula will remain the same, only this xi will be the midpoint of the class interval. Just remember this xi will be the midpoint of the class interval, remaining everything will remain the same. Now let us take a small example of a continuous series. You can see the marks class on the left side. So the midpoint of the class is 27.5. Taking the log of midpoint, we get log of x is 1.4393, and when we take the product of frequency and log of x, we get 14.393. Let us do this for all the columns, and finally we get the summation of f into log x as 161.0865. Now we'll just substitute these values in the formula. So n stands for 100, or n is equal to 100, and fi log of xi is equal to 161.0865. Replacing these values, we get g is equal to nt log of 161.0865 divided by 100. So the value of g is 40.813 marks. Okay, this is how simple it is. We have calculated the value of geometric mean. So now just seeing the difference for geometric mean in individual series, discrete series and continuous series. In individual series, the n stands for the number of items. In discrete series, we take the product of frequency and log of x of I. In continuous series, the formula remains the same as that of discrete series. Only thing is, here the value of xi is the midpoint of the class interval. Just remember this. Now coming to geometric mean of combined group. So if n1 and n2 are the sizes and g1 and g2 are the geometric means of the two series, then the combined mean is given by the formula log of g is equal to n1 log of g1 plus n2 log of g2 the whole divided by n1 plus n2. Let us see the derivation for this particular formula. We'll take two series. Let x1i where I ranges from 1 to n1 and x2j where j ranges from 1 to n2, and n1 and n2 are the number of items of two series. Then by definition the geometric mean of the first series is g1 is equal to x11 multiplied by x12 and so on up to x1 n1 the whole raised to 1 upon n1. Now taking log on both sides as we have done earlier, we get n1 log g1 is equal to summation of I equals to 1 to n1 log of x1i. Similarly, we get the value of g2.
G2 is equal to x21 into x22 and so on up to x2n2, the whole raised to 1 upon n2. Now taking log on both sides as we have done earlier, we get log of G2 is equal to 1 upon n2 summation of j equals to 1 to n2 log of x2j. And therefore n2 log G2 is equal to summation of j equals to 1 to n2 log of x2j.
We'll label these two equations as equation 1 and equation 2. Now let us find out the geometric mean for the combined group. So geometric mean of combined series is given by g is equal to x11 multiplied by x12 and so on up to x2n2 and the whole raised to 1 upon n1 plus n2. Now again, as we had discussed before, log of m into n is log of m plus log of n. We get log of g is equal to 1 upon n1 plus n2 the whole multiplied by summation of I equals to 1 to n1 log of x1i plus summation of j equals to 1 to n2 log of x2j. Now the value of this summation of I equals to 1 to n1 log x1i and summation of j equals to 1 to n2 log of x2j we have already found out in the previous slide, and we had labeled them as equation 1 and 2. We will simply substitute those two equations in this equation and we get log of g is equal to 1 upon n1 plus n2 the whole multiplied by n1 log g1 plus n2 log g2. Now opening the brackets, we get log of g equals to n1 log g1 plus n2 log g2 the whole divided by n1 plus n2, and this is how we found out the formula for geometric mean of combined group. And that's all for today. This was a very simple topic, and in the next lecture we'll study about the merits and demerits of geometric mean. Thank you.